Okay, so today our topic is the Boolean, a portion of the Boolean algebra, which is the Karnaugh map or the Karnaugh graph. So this is our topic, Karnaugh map, or sometimes it is also says as graph. So first, what is the
सर ये
Karnaugh map? Yes.
सर ये कान्हा मैप तो डिजिटल इलेक्ट्रॉनिक्स का पार्ट है ये
हाँ.
मैप
So actually, what is the Karnaugh map? Basically, in your Boolean algebra, sometimes you see one type of question where you have to minimize the Boolean expression. Now, so a Boolean expression will be given, and by using the Boolean algebra property, you have to minimize the form, like the circuit problem also. A complicated circuit is given, just form the DNF or CNF of the circuit, and after that simplify it by using the Boolean logic. But sometimes it is very much difficult to simplify this problem, so just by using the Boolean algebra properties or the axioms. So that's why Karnaugh find one way that by creating some table or some map between these variables, these Boolean variables, you can easily minimize the Boolean expression. So that means suppose one Boolean expression is that means suppose f of x1, x2 and x3. So this f of x1, x2, x3 is suppose x1, x2 bar, x3 and plus x1, x2 bar, x3 bar and plus x1 bar, x2 bar and x3 and after that plus x1 bar, x2 bar and x3 bar. So this is one of the DNF form, na? This is one of the DNF form. Is it a DNF form or a CNF form? What do you think? Is it a disjunctive form or a conjunctive form? What is it?
The DNA form.
It's a DNF form because these components are actually is on the form of CNF and there is some plus. That means this is actually a sum of product, a DNF form. Now how to simplify this form? So if you just use the Boolean algebra, then first you will actually, this is x1 x2 bar and this is x1 x2 bar and x3 bar. You will take it common, x1 x2 bar, and you will take x3 plus what, x3 of bar, and similarly from these two portion you will take x1 bar, x2 bar, and you will get it x3 plus what, x3 bar. And after that this x3 plus x3 bar, actually it is what, 1, and this x3 plus x3 bar, this is also what, 1. So after that it will be x1 x2 bar
सर
and yes,
इंटरप्टिंग इन मिडिल सर समवन इज ट्राइंग टू जॉइन
but I can see anyone here. Just tell me to join
शुभम
again. Okay,
यस सर शुभम इज सेइंग दैट लेट हर इन लेट
just
शुभम
tell
सेइंग
me to join again.
ओके सर
I can't see anyone. Okay. So now this is x1 x2 bar and this is x1 bar x2. Now again we will take x2 bar common and we will produce x1 plus x1 bar and this is what, x2 bar. So this is again 1, so that means 1 dot x2 bar, and this is in the simplified form, it will gives you what, x2 bar. Is it okay to everyone, this simplification by using the Boolean axioms or the Boolean logic? Is it okay? Hello, is there any queries or doubt in this Boolean simplification? I can't hear anyone.
No, sir.
Okay, so I think it is
सर
okay.
एक बार फिर से समझाना सर एक बार
कौन
फिर
सा
से
पार्ट
समझाना
समझा है, बोलो.
ये वाला सर ये
देखो ये पहले दोनों पार्ट से, from the first two part we take x1 x2 bar common, so then what you will get, x3 plus x3 bar, and from the second two part we take x1 bar and x2 bar common, that means you will get again x3 plus x3 bar. And you all know that in the Boolean expression this is the disjunction and x3 plus x3 bar always represent 1 and x3 dot x3 bar always represent what? 0. So these are the basic properties of the Boolean algebra. And x3 plus some variable x3 bar, this is equal to 1. So we just put it 1 here. So that means this value is x1 x2 bar 1 and plus x1 bar x2 bar and dot 1. So now this is a dot with 1, so that means it will be the same value at x1 x2 bar and it is x1 bar x2 bar. So again we take this x2 bar common and you will get x1 plus x1 bar, it is again 1, that means 1 dot x2 bar and this is what? X2 bar. So it is the simplification by using the Boolean algebra. We already did this simplification in our offline class. But now Karnaugh actually represent it diagrammatically. That means Karnaugh represent this all these DNA variable, these DNA portions by a diagram. And after that, by using this diagram, you can simplify your expression very easily. But here one of the restriction is your expression should be in the DNA form and the complete DNA form. So this is one of the restriction or the prerequisite of this method, that to apply the Karnaugh map, your expression should be in a DNA form. Okay, so your given expression should be in the form, in the DNA form, and not only the DNA form, it is actually a complete DNA form. So complete DNA form means, what is complete DNA form? That means suppose your variables, there are 3 variables x1 x2 and x3 in your problem, but in your expression there is only x1 and x2, no x3 is there. And then plus suppose x1 x2 bar x3, and then plus suppose x1 bar x2 bar and x3 bar. So first of all you have to make it complete. It is not a complete DNA form, it is a DNA form but not a complete DNA form. So to make complete DNA form, first you have to take x1 plus x dot 1 here, na? And plus it is okay x1 x2 bar and x3, and is x1 bar x2 bar and x3 bar. After that take this 1 as x3 plus x3 bar, because you all know that, and then product it by using x1. After that you will get x1 x2 x3 and plus x1 x2 x3 bar, and sum it with these two remaining portion x1 x2 bar x3 and plus x1 bar x2 bar and x3 bar. So this is the complete DNA form, but it is not the complete DNA form, because you can see here x1 and x2 is there but no x3 is there. So that's why if it is not a complete DNA form, so first you have to make it complete DNA. After that you can use the Boolean expressions. Use this to the Karnaugh maps. Now how to use the Karnaugh map and what is the simplified way? So if there is 2 variables, am I audible to everyone?
Yes, sir.
Okay. So if there is 2 variables, this is very important. If there is 2 variables, suppose x1 and x2. Instead of that, you may get x and y also. Then produce the table as, then your table should be in the form, in this form, that here you will get x2, x1, here x1 bar, and here x1, x2, and here x2 bar. Okay. So this is your table for the 2 variables. So if it is a 2 variable expression, only x1 and x2 expression, then produce this table in this way, that here x1 and x2, and here x1 x1 bar, here x2 x2 bar. That means in this box your expression is what? What is your expression? x1 x2. Here expression is x1 x2 bar, here expression is x1 bar x2, and here x1 bar x2 bar. Is it okay to everyone? Is it okay to everyone?
Yes, sir.
Okay.
Yes, sir.
So now suppose you have to simplify this expression. So suppose this is problem that simplify this expression x1 x2. Basically in your exam two variable problem will not occur. Obviously it will be a three variable problem, because two variable problem you can easily do it by just seeing it, by just taking one part common. Don't need to be use Karnaugh maps. But just to understood that this is x1 x2 and suppose plus x1 bar and x2. This is your expression and you have to simplify it. And you can easily see that you just take the x2 common, it will be x1 bar, and it is 1, so 1 dot x2, it will be x2. But what we have to do? So we have to put 1 in the expression box. So here it is x1 x2. So the Karnaugh map of this problem is, the Karnaugh map of this problem is like x1. So just put it x1 x1 bar, and it is, just take it here, it is x2 and it is x2 bar. Now here x1 x2 is present, so put here 1, and x1 x2 bar is not present, put here 0. X1 bar x2 is there, so put here 1, and x1 bar x2 bar is not there, so put here 0. So this is the Karnaugh map of this expression. Okay. After that, make some pair with that one. After that, make some pair or combination of pairs using this one. So that means you can easily pair that. Is it okay? You can easily make the pair between this one. So this is the pair what you can build from these two one. So that means now the important thing is take the common from this left hand side and take the common from this upper side. You have to take the common. So what is common in from the left hand side? What is common? Nothing. So here common is 1. Na? And what is common from the upper side? x2, because it is only one line. So that means your simplified expression is 1 dot x2. That means simply x2. Is it clear to everyone? Now we have to take more and more problem to understood the process. So it's just the start. Is it clear now? We have to take the common from the left hand, the left column. That means the pair assigned values. So common between this x1 and x1 bar, no common. That means it is 1. So if, and this is x2, so it is only one value. So we take 1 dot x2 and it is 1 dot x2 is equal to x2. This is a two variable form. Now again we are just taking three variables now. So if there is three variables, take it. If there is three variables, then we will take the table in this way. This is our table. So just take one box also, not just necessarily make the table always. Just take one box, and where you have actually 1 2 3 4 three variable means total 8 values will be there. So start with x1 bar here, and here you will take the combination of x2 and x3. So combination of x2 and x3 means starting with x2 x3, then x2 bar x3, then x2 bar x3 bar, and then x2 x3 bar. So these are the combinations of the x2 and x3. So that means after we can take the all the combination x1 x2 x3, then x1 x2 bar x3, then x1 x2 bar x3 bar in this way. Is it clear how to make the box first? Then we simplify the problem. Is it clear to everyone? Making the box.
Yes.
Okay. Now simplify the problem. Now simplify one Boolean expression which is x1 x2 bar x3 plus x1 x2 bar x3 bar plus x1 bar x2 x3 and plus x1 bar x2 x3 bar. So this is the Boolean expression. So now actually simplifying it is little bit difficult to some of the students. Obviously some intelligent student will make that also by using the Boolean logic algebra, but you all can simplify it by using the Karnaugh map. So how to do it? So just place 1 where this expression occur and place 0 where not. So now fill the table. So you can see x1 x2 x3 first. Is there x1 x2 x3? No. Or just take it x1 x2 bar x3, where it is x1 x2 bar x3. So x2 bar x3, here it is x1 x2 bar x3, put it by 1. Is it clear how to put it? X1 x2 bar x3.
Yes, sir.
Okay, after that x1 x2 bar x3 bar, that means the next bar, the next box, x1 x2 bar x3, put it 1 also. After that x1 bar x2 x3, x1 bar x2 x3, so put it 1. Okay, and then x1 bar x2 x3 bar, x1 bar x2 and x3 bar, so put here 1 also, and fill the other boxes with 0. Now what we have to make? We have to make the pair. So how you can build a pair? So there is one pair you can make there, this, and after that also you can make this as a pair, the starting and what, the end. No, because actually this is like a cycle. So this is x2 x3. So if you take it again at the first, so you will make some pair because there is a common between these two. What is common? x2. X2 is common between these two values, so you can make them as a pair also. So now we have two pairs. Now again we have to do the same things. So what is your simplified value? So first take this pair and take the common values from here. It is only one value, so take it as x1. Okay, and take the common from the column. From the column, what is common? From the column, what is common?
X2 bar.
What?
X2 bars.
X2 bar. So take it x2 bar. Okay, so x1 and put it here x2 bar. So it is the first expression, and after that give a plus, and again take the second two terms, and for the second terms from the second pair you can see that the first is x1 bar, it is only there, and common between these two values, what is the common between these two values? It is x2,
X2.
and this is the simplified expression. And I think it is simpler than using the Boolean algebra properties. Is it easier or not?
Yes, sir.
Obviously it is easier. So now we are taking the first problem, what we, where we start this expression. Na? This expression, we will produce the Karnaugh map for this expression now. Now the Karnaugh map of this expression. So to build it, we just form again one of the such type boxes here, and in these boxes we make 1 2 3 and 4 holes, and here this is x1, this is x1 bar, x2 x3, then it is x2 bar x3, this is x2 bar x3 bar, and it is x2 x3 bar. Okay, after that fill it. What is the first value? First value is x1 x2 bar x3. So x1 x2 bar x3, it is 1. Then x1 x2 bar x3 bar, it is 1. Then x1 bar x1 bar x2 bar x3, that, then x1 bar x2 bar x3 bar, that. Na? Is it okay? Is it correct? Okay.
Yes.
After that you can easily make them pair. Not only a pair, you can make two pairs with that, not one pair. So there are actually two pair here, so we can make a square type of pair. That means a set of two pairs here. So now take the common from the row. So what is common from the row? Common from the row is 1. Na? Is it okay? And what is common from the column?
Yes, sir.
What is
Yes, sir.
common from the column? It is
X2 bar.
x2 bar. So that means your answer will be x1 dot x2 bar. It is x2 bar. Okay, 1 dot x2 bar. That means answer is x2 bar. Okay. Now is it clear to everyone how to take this Karnaugh maps?
মানে স্যার ওপরে কলামে যেগুলো লিখবো ওগুলো তো এই সিকোয়েন্সেই লিখতে হবে, যে এক্স
হ্যাঁ
টু
এই
এক্স থ্রি,
সিকোয়েন্সেই
এক্স টু
লিখবে।
বার এক্স থ্রি।
yes 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 it will be better, you will do that, otherwise you can't pair it, এই এদিক ওদিক চলে যাবে না। So it is important to
হুম হুম।
take the pair in this way, that first x2 x3 x2 bar x3, then x2 bar x3 bar, and then x2 x3 bar. That's why Karnaugh mentions all these boxes and by the variables, that you have to put it in this way. So after that we will take some DNA form which is not in the complete form, but you have to make it complete. So just I am taking one of this type of form. So suppose okay, just take it one of the form, that simplify this expression, that f of x1 x2 x3, this is equal to x1 into x2 x3 and plus x3 bar. Okay, you have to simplify that, but you can see this is not a DNF form or a complete DNF form. Is it a DNF form? Is it a DNF form?
No.
No.
No,
So
sir.
first you have to make it DNF form, just product it, not very much difficult, just product it, you will get x1 x2 x3 and plus what, x1 x3 bar. Now if you see, you can see here the x2 is missing from the second expression, so we need this, we need this expression to make it complete. So that's why we take here 1 and we replace this 1 by x2 plus what, x2 bar. So this is our aim. So we take 1 here and then we replace this 1 by x2 plus x2 bar to make it complete. So just take it, x1 plus x2 x3 plus x1 into what, x2 plus x2 bar and x3 bar, just make it. So that means it is x1 x2 x3 plus what, it is x1 x2 x3 bar plus x1 x2 bar and x3 bar. So this is the expression. After that make the Karnaugh maps. Now you are ready to make the Karnaugh map, and again from the table like the previous way, make the 4 boxes here, 1 2 3 4 boxes, and starting with x1 bar, here x2 x3, here x2 bar x3, here x2 bar x3 bar, and here x2 x3 bar. Now put here 1 in the x1 x2 x3, then 1 in the x1 x2 x3 bar, here 1, and 1 in the x1, where is another one, 1 in the x1 x2 bar x3 bar, there is another one, na, x1 x2 x3 bar. So one is x1 x2 x3, another in the x1 x2 bar x3 bar, and another in the x1 x2 x3 bar. So these are the 3 values. Is it okay? It is x1 x2 x3,
Yes,
it
sir.
is x1 x2 bar and x3 bar, and it is x1 x2 and x3 bar. Now make the pairs. So how you can make the pairs? How you can make it? So one is that pair, na? So first you can make them as a pair. So this is the first pair, what you can make. This is the first pair. And from this pair, actually your expression is x1, and what is the common value? Common value is x3 bar, na? Is it okay?
Yes, sir.
X1, and from these two value, common value is x3 bar. So we take it x1 and x3 bar. So after that, you can also make another pair. And what is the another pair? So another pair is that. So you can take it from here, and you can take this from here at the end, two end values. And here also you will get plus x1 and plus what? What is the common from these two? x2. Na? x2 is the common from these two values, so this is x2, and this is your simplified form for this given expression. So by using the Karnaugh maps in this way, you can easily simplify your Boolean expression. Okay. So in your exam, actually, you may get 3 or 4 variables. So 4 variable is not so much common in your exam, but sometimes you may get. So suppose you have one expression left in this way, that there is one and you can't make it pair in any way. It is not possible to make the pair. So that's, in that case, you will just place this variable here. So x1 x2 bar, x1 bar x2 bar, and x3 here, because you can simplify this expression. So, and this is your answer. If it is not possible to pair these variables in any way, so then just leave it. Okay. So we are taking some more problems, because it will be easier to understood then. Again, another problem, and which is simplify the Boolean expression f of x1, x2, and x3, and this expression is x1 plus x2 plus x3, and dot, it is x1 bar plus what, x3. So at the starting we have says that the Karnaugh graph or Karnaugh map only works for the DNF form, not for the CNF form. But you can see this is actually a CNF form, na? This is a CNF form, conjunctive normal form. So that's why you can directly use the Karnaugh maps here to simplify it. So that's why first you have to convert the CNF to DNF, and there are so many conversion way. You can first make the truth table, the Boolean table from the CNF. After that, you can take the 1, 2 from the DNF, or you can just fill the missing variables here. I think filling the missing variables is easier than doing the table here. So just multiply them. Simply multiply them first. It is x1 x1 bar, then what, x1 x3, or first taking with the x1, that we are multiplying this whole value with x1. So x1 x1 bar, then what, x1 bar x2, then plus x1 bar x3. Then I am multiplying the whole term by x3, and you will get x1 x3 plus what, x2 x3, and plus x3 x3. Now use the Boolean algebra property, simply Boolean algebra. So it will be 0, na? x1 x1 bar, x1 x1 bar is
Yes.
0.
Yes.
And this x3 dot x3 is again what, x3. It is x3 actually. It is x3, and it is simply 0. So from the next time we will not write that. We will directly put, actually just discard this term. We will not write it. So that means we will only take the x1 bar x2 plus,
सर एक बार फिर से एक्सप्लेन कीजिए ना.
हाँ, from the Boolean property, that x1 dot x1 bar is what, 0. It is a Boolean property.
0.
So
Yes sir,
why
0.
we take 0 here? Because 0 plus that term will be that term again. So why we put 0? So from the next time, whenever we multiply it, we will directly discard this term. That means x1 x1 bar, we discard that. We will not write that term. And again, whenever you take the same term x3 dot x3, you will get only one term x3. So that's why from the next time we will directly write down this as x3. But here we just expand the whole expression. After that we are writing that. So after discarding this as 0, it is x1 bar x2, and after that what is that term? That is x1 bar x3. After that it is x1 x3, and it is x2 x3, and it is simply x3. So this is our next term. This is our term now. Now again we have another problem. So in this term x3 is missing, in this term x2 is missing, here x2 is missing, here x1 is missing. So many terms are missing here. So that means this is not a very simple expression to simplify. So again you have to first fill these missing variables. So how to fill that? So just do it. So it is x1 bar x2 into what? x3 plus x3 bar. Is it okay? We fill the missing variables with the x3. Is it okay to everyone?
Yes, sir.
Next, we fill the x2. So x1 bar, we fill it with x2 plus x2 bar, and then what? x3 plus, again same thing, x1, then what? x2 plus x2 bar, and then x3 plus x1 plus x1 bar, and then x2, then x3, and plus, here we need two terms, so x1 plus x1 bar, after that x2 plus x2 bar, and after that x3. This is the term. So now you have to take the product of all these terms. And what are the product? So x1 bar x2 x3, x1 bar x2 x3 plus x1 bar x2 x3 bar plus x1 bar x2 x3, okay, and plus x1 bar x2 bar x3 plus x1 x2 x3 plus x1 x2 bar x3 plus x1 x2 x3. So many terms repeated multiple times, so we can omit this term in the next step. So x1 bar x2 x3, and after that there will be again so many terms here. And what are the terms? So first of all, multiplying it, you will get this type of expression, x2 x3 plus x2 bar x3. This is the term. And after that we will multiply it by x1, so that means you will get four expression here. One is x1 x2 x3, after that plus x1 x2 bar x3 plus x1 bar x2 x3 and plus x1 bar x2 bar and x3. So this is the whole expression after just expanding the whole form. So it is just one of the expression for needed for the calculation, nothing else. So x2 x3 plus x2 bar x3, that's required for the only for the direct calculation. Okay, now what is the next step? In the next step we will omit the like terms. So x1 x2 bar x3, it is already here, x1 bar x2 and x3. Okay, then plus the x1 bar x2 x3 bar, we are taking that, plus, okay, it is already taken this term, you can see that na, it is already taken in the first term, x1 bar x2 x3, so we will discard that because some of the same term will be again the same term in the Boolean algebra. So that's why we will not take that term x1 bar x2 x3. So next x1 bar x2 bar x3 bar, we have to take that x1 bar x2 bar x3, this is the new term. After that plus x1 x2 x3 new term plus x1 x2 bar x3, x1 x2 bar, okay, I think it is in the first term na, x1 x2 bar x3, x1, no it is not, okay, take it, x1 x2 bar, then what, x3, then it is in the first term, in this term, so neglect it. Then x1 bar x2 x3, it is also present at the first term, x1 x2 x3 already taken, x1 x2 bar x3, x1 x2 bar x3, it is also already taken, x1 bar x2 x3, x1 bar x2 x3, x1 bar x2 x3 at the first term already taken, and then x1 bar x2 bar x3, x1 bar x2 bar x3, here we have x1 bar and x2 bar x3. So that's why we will not take all these other terms. So these five terms are our simplified DNF form. Now tell me, is there any doubt? After that we will make the Karnaugh map. Just tell me, is there any doubt or not? Am I audible?
Yes, sir.
Okay.
Yes, sir.
So this is just a simplifications of the CNF form. So after making these simplifications of the CNF form you can actually make the Karnaugh map. Make the Karnaugh map, and the Karnaugh map is again the same thing what you will get here, just x1 x1 bar, it is x2 x3, it is x2 bar x3, it is x2 bar x3 bar, and it is x2 and x3 bar. After that, put the variable x1 bar x2 x3, that is 1, x1 bar x2 x3 bar, x1 bar x2 x3 bar, put it 1, x1 bar x2 bar x3, x1 bar x2 bar x3, put it 1, x1 x2 x3, put here 1, and x1 x2 bar x3, put here 1. Okay, now you can see the pair easily. So this is the first pair, that means the first combination of two pairs you can make it. And from this expression, now tell me what is the term. From this expression, what is the term? Tell me.
x3.
It is x3. Yes. So because from this two term your common term is x3, and from this two term your common term is 1. So that's why it is a x3 expression. Now we have another expression, na? Another pair, possible pairs, and it is that. It is the another pair. And what is this term? x1 bar
x1 bar
x2.
x2.
x1 bar x2. So this is the simplified form of the given expression, that x3 plus x bar x2. Okay, so just I think expansion is not very much difficult. So just it takes little bit time to make it, or omitting the similar terms, and after that you can easily generate the Karnaugh maps, and you can easily simplify your given variables. Okay, and it is for the 3 variables, and if it is a problem of the 4 variables, suppose, so then just make the table in this way. So for the 4 variables, and for the 4 variables you have so much time, but the basics concept is already over. So now you all can practice that, and if you actually get any problem, then we will again discuss this in our next class if there is any doubt or any problems. But this is very much important, and also not very much difficult for taking it to the exams. So that's why just practice it. If you don't understand the process, then ask me. Okay, I will help always. So now for the 4 variables, suppose function, it is x1 x2 x3 and x4. So just make this type of table, and according to the Karnaugh, so obviously 4 means there will be a 16 boxes here you will get, and 4 line and 4 boxes, 4 columns, and this is the figures. And where you have to take the variables in the previous way, in the left side we will take x1 x2, in the upper we will take the x2 and x3 and x4. So here we take x3 x4, we will take x3 and x4, and from here we will take the x1 and x2. So in this way, so first variable is x1 x2, here this is x1 bar x2, here this is x1 bar x2 bar, and here it is x1 x2 bar, like the previous way. And here it is x3 x4, it is x3 bar x4, it is x3 bar x4 bar, and it is x3 and x4 bar. So that's the table. After that, if some expression is given, just take one homework to make it. Just take one problem in the 4 variable x1 x2 x3 and x4, and the expression is x1 bar x2 bar x3 x4 plus x1 bar x2 x3 x4 bar plus x1 x2 bar x3 x4 bar plus x1 x2 bar x3, and I think 1 2 3 4, and okay, take it x1 x2 and x3 bar and x4, and plus x1 bar x2 bar x3 and x4 bar. So Without using the Karnaugh maps, it is very much difficult to produce it. So that's why in this type of expression, always try to use the Karnaugh map for the simplification process. So this is one of the example or the exercise for the 4 variables. And just from the 3 variable homeworks, just take some more homeworks. And first is one of the DNF CNF form, where you have to make the DNF form x1 x2 x3 is equal to x1 plus x2 bar and plus x3 dot, it is x1 bar plus x2 bar plus x3 and dot x1 plus x2. So that means first you have to make this in the DNF form, and after that you can do whatever you need. Then number 3, this is another problem, f of x1 x2 x3 x2 x3. Basically this type of form is most popular for the exams, because you have to first take the DNF CNF to DNF, and after that you have to make the Karnaugh maps. So x1 plus x2 and then dot x2 bar plus x3. And number 4, some of the direct expressions what you can get is f of x1 x2 x3 x1 x2 x3 is equal to x1 x2 x3 plus x1 x2 bar x3 plus x1 x2 bar x3 bar and x1 x2 x3 bar and plus x1 bar x2 and x3. Okay, so I think this problem actually 1 2 3 and 4. So just take one more expression and 5 homeworks, it is sufficient for the practice. And it is also 4 variable problem and with 7 terms. I think don't need the 4 variable problem, exam এ আসবে না বেশি থাক, আর একটা 3 variable দিয়ে দিই, 3 variables x1 x2 x3 plus x1 x2 bar x3 plus x1 x2 bar x3 bar plus x1 bar x2 bar x3 bar and plus x1 bar x2 and x3 bar. Okay,